You know, we always obsess over the big flashy stuff,
Mm.
the giant screens, the projectors, the final image.
Mm.
But we never really talk about the very first step, the input slot.
Right.
I mean, if you're running a command center and your input card chokes the signal, that amazing screen is just, well, it's just displaying expensive garbage, isn't it?
It's the classic bottleneck problem. It really is. You can't output what you didn't get in the door cleanly.
Exactly.
And that, I think, is exactly why we're digging into the Kramer MC3-2HI today.
So this is a dual-input HDMI card. It's for their modular matrix systems.
Huh?
And I have to say, the sticker shock it's pretty real.
Yeah.
We're talking around $1,300
Mm-hmm.
for 2 inputs. That feels like a lot for a little component that just slides into a chassis and, disappeared.
It does. It does. Until you look at what it's actually doing, the data density, you're not paying for the plastic ports. You're paying for the sheer bandwidth.
What are we talking about here?
This thing is engineered to handle 18 gigabits per second.
18 gigs. Okay, so that brings us to the specs. 4K at 60 hertz, that's pretty standard now. But that 18 gig number, that tells me we're dealing with 4.4.4 color space.
And that's the whole ballgame. That's the differentiator.
Right.
I mean, if you're just watching Netflix at home, 4.2.0 compression is fine. You're not going to notice the color data they shaved off to save space.
This isn't for that.
No. This card is built for Pro AV. Think medical imaging, flight data, or huge spreadsheets on a video wall.
Yeah, where you absolutely need crisp text. That's where you see it, right?
Yeah,
You compress the color, red text on a black background just turns to mush.
exactly. It gets all fuzzy. This card pushes the full, uncompressed color signal, no chroma subsampling at all.
So it's pure.
It's pure. It's moving 6 gigabits per graphics channel just to make sure what you see is pixel for pixel accurate. And that includes support for things like HDR10 and deep color. It's a massive data pipe.
It's pretty interesting that they managed to squeeze all that throughput into a modular card without it, basically becoming a space heater.
Right.
Usually when you start pushing 18 gigs, things get really hot really fast.
And that is arguably the most impressive piece of engineering in this whole thing. It draws about 5 watts.
5 watts, that is absurdly low.
It is. And what that lets you do is stack these cards in a matrix. You can fill a chassis without needing like a dedicated cooling plan for it.
So you keep that high bandwidth throughput on every slot without blowing your thermal budget.
You got it.
Okay, I do want to challenge the audio specs a little bit though.
Go for it.
I'm looking at the sheet here, and it lists support for 32 channels of digital stereo uncompressed signals. That feels aggressive. For a 2-port card, is that really practical?
It's less about practicality and more about not being a bottleneck for the audio either. It's about not stripping the signal.
Oh.
So if your source is sending out Dolby True HD or DTS HD, a full 7.1 studio mix,
Yeah.
the card just passes it straight through, untouched.
It's a pass-through.
Exactly. It's just ensuring the audio fidelity perfectly matches that 4.4.4 video. It makes the whole matrix a transparent router for whatever studio grade stuff you throw at it.
And I have to assume, since it's handling high-value content, it's got the HDCP 2.2 handshake built in.
Oh, mandatory. Absolutely. If it didn't, you'd plug in a protected Blu-ray or broadcast feed and just get a black screen. It has to handle that encryption just as fast as it handles the raw data.
So what we have here is this strange but powerful mix of total flexibility and raw power.
Mm-hmm.
You slide this little thing into a matrix, and suddenly those 2 ports can go anywhere, carrying a signal that hasn't been stepped on or compressed in any way.
That is the definition of professional modularity. You aren't forced to compromise quality just to get the routing flexibility you need.
It does make you worry a little about the next cycle, though.
What do you mean?
Well, if 4K already requires this kind of heavy lifting 18 gigs a second just to keep the color accurate, the infrastructure jump to 8K is going to be, it's going to be painful.
That is the elephant in the room, isn't it? We are pretty much maxing out what copper can do with these specs.
So what's next?
When we jump to that next resolution tier, we're not just going to need new cards. We're going to need an entirely new physics for how we move that much data around a building.
Something to keep in mind before we all start demanding more pixels. Thanks for listening to this deep dive.